Alright, so today while I'm out, we all are going to learn about these things called Logarithm Properties. And this is a super short section. There's only 4 major properties. It's probably taking me the most amount of time to describe the last one to you, so let's see if we can run through the first 3 very quickly. We're going to use these properties a little bit more on Monday when we start solving logarithmic equations, but for today you guys are just going to use it to try and evaluate some basic expressions. So let's jump right into it. So the first property is called the product property. And the basic gist of the product property is if you see 2 logarithms of the same base being added together, you can combine them as multiplications. So what it'll look like is this. If you had something that was like log base m of a plus log base m of b, put these in parentheses, what you can do is you can turn this into log base m of a times b. Alright, so 2 logs of the same base being added together, we can combine them as multiplication. Okay, so real quick, let me just show you how this works in terms of an example that we can actually check. So let's say we had something like log base 2 of 2 plus log base 2 of 4. Okay, now we can evaluate these really easily just off the top of our heads. Log base 2 of 2, 2 to what power gives me 2, that would be 1. Log base 2 of 4, 2 to what power gives me 4, that would be 2. And 1 plus 2 is 3. So we know the answer to this has to be 3. Now if we try to use this property up here, what it says is if we have these 2 logarithms of the same base being added together, we can combine them as multiplication. So we can take the 2 and the 4 and multiply them together and get 8. And log base 2 of 8, 2 to what power is 8? The answer to that is 3. So we can tell that this property works. Now, obviously, if we have ones where we could evaluate, there'd be no reason to use the product property. However, what if we were given something like this? Log base 6 of 4 plus log base 6 of 9. Okay? Here's one that we can't evaluate unless we use this property, because I don't think anyone off the top of their head knows what log base 6 of 4 is. I also don't think you know what log base 6 of 9 is. However, if I turn this into the log base 6 of 4 times 9, 4 times 9 is 36. And this is a lot easier because log base 6 of 36, 6 to what power is 36? The answer to that would be 2. So this property will allow us to evaluate some things that could not be evaluated without the use of the product property. Okay? But I'll also make a side note here, because once we start doing equations next week, you'll also see some things that look like this, say like log base 3 of x plus log base 3 of x minus 4. You can also use the product property with this, even though it involves variables. You could change this into the log base 3 of, and you can multiply this and this together. And when we do that by distributing, we would end up with x squared minus 4x. So you can also use this property with variables as well. Okay. So we have the product property. The second one that we have is called the quotient property, which is very similar to the product property, except instead of adding 2 logarithms of the same base, this time we are subtracting 2 logarithms of the same base. And when that happens, what we can do is we can put them together as division. So for example, if you saw log base m of a minus log base n of a, mess this up, log base m of a minus log base m of b, what you could do is change this into log base m of a divided by b. Okay, and we can check this same as what we were doing kind of on the last problem. If you had something like log base 2 of 16 minus log base 2 of 4, for example, 2 to the 4th power gives us 16, so the answer to this would be 4. And 2 squared gives us 4, so the answer to this would be 2. And 4 minus 2 is 2, so we know the answer to this is 2. But if we try to use the quotient property here, because we have 2 logs of the same base being subtracted, we can take the argument, or the number inside of the logarithm, and we can divide them. So what this will become is log base 2 of 16 divided by 4, which is 4. And log base 2 of 4, 2 to the second power is 4. So we can see that this property works the way that we want it to. Now, also like last time, there's certain things that we wouldn't be able to evaluate without the use of this property. So let's say, for example, we had something like log base 7 of 98 minus log base 7 of 2. Okay, we don't know what 7 to what power gives us 98. We don't know 7 to what power gives us 2. So we could not evaluate these as their standalone. We couldn't evaluate them. However, if we use the quotient property, we can do log base 7 of 98 divided by 2, and 98 divided by 2 is 49, and this is a lot easier because 7 to the second power gives us 49. Okay, so we have an idea of how we can use this property to help us evaluate things, and just like the product property, this would also work with variables. So if you had something like log base 11 of x minus log base 11 of x minus 2. This could be combined into the same logarithm as log base 11 of x divided by x minus 2. Okay? So we have the product property and the quotient property. They both involve logs of the same base. If they're being added together, we can throw them into the same logarithm as a product. And if they're being subtracted, we can throw them into the same logarithm as a quotient. Okay? And then the final property for us here is something, or sorry, the final of the easier properties is something called the, I'm spelling this wrong, called the power property. And the power property, it's easier for me to write it down. Here's what it looks like. So if you have something like log base n of a raised to the b power, what we're allowed to do is we can take this exponent and put it out on the front as multiplication. Okay, so what this would look like is b times log base n of a. Alright? So this comes out to the front as multiplication. Okay, and just like all of our other ones, we can check this. So let's say, for example, you had something like log base 2 of 16. Okay. Well, this could be rewritten as log base 2 of 16 is the same thing as 4 squared. Okay? So I just rewrote this to show how we can use the product property. Now, we already know off the top of our head 2 to the 4th power. If we don't know the answer, this should be 4. I'm using the power property. If I took this exponent and put it out on the front, this would turn into 2 times log base 2 of 4. Okay. Log base 2 of 4. 2 squared is 4, so this would turn into 2. And then we already have this 2 out in front. 2 times 2 is 4. So we can see that this property works the way that we want it to. Now, some other ways that you can use the power property. Let's say, for example, you saw something that looked like this. Log base 3 of, 27 raised to the 11th power. Okay. Well, if you saw something that looks like this, I don't really think there's anybody in here who would want to do something like 27 raised to the 11th power. That would be a massive, massive, massive number. However, using the power property, we can still come up with an answer for this, because if I take this 11 and I put it out on the front, it's multiplication, this would become 11 times log base 3 of 27. Well, log base 3 of 27 is 3. 3 cubed is 27 times 11. We can tell the answer to this is 33. Okay, so it allows us to evaluate some things that the calculator couldn't even tell me what 27 to the 11th power is, but it doesn't matter because I can take that 11 and put it out on the front as multiplication. Okay. This can also be used with variables, which we'll see a bunch of different times on Monday. Okay, and also we'll see it in a couple different ways. You can go like this. Let's say you had 2 times log base 5 of x. You could take this 2 and you could put it back here as an exponent if you need to, depending on what the problem is. Or If it helps you out, you could also take something like log base 7 of x to the 5th. And if it helps you, you could take the 5 and put it back out front as multiplication. So you can use this property in either direction. Just depends on what's going to help you the most for the particular problem that's given to you. Okay? So those are our 3 smaller properties we have, and you'll actually use these ones the most, but they're a little bit easier, are the product property, the quotient property, and the power